Welcome to another episode on Hands on Mac. So in today's video, we're going to be discussing about gas oil system. The gas turbine is a dual fuel engine. It can be operated on natural gas as well as it can be operated on gas oil. So whenever there is a non-availability of the natural gas, the gas turbine will be operated with gas oil system. So as you can see from the drawing, this is how a gas oil system is designed for a typical gas turbine power station. So let's go through it in detail. So this is from where it starts. This is from the fuel oil from a supplier. It could be anyone. As soon as the fuel comes, it gets into a fuel metering station, because we need to know, the customer or the supplier needs to know how much fuel the customer is consuming. So a tariff meter station is very much important. So the fuel will be going through the tariff metering station. As you can see, I have provided a bypass line over here. In case of any maintenance on this fuel metering station, we can simply open the bypass line and we can utilize the bypass line to fill the tanks, so that the gas turbine can be operated without any interruption. So as soon as the gas oil comes into this tank, normally this tank is known as a untreated tank, or where we keep the dirty oil, because we don't know what are the substances or what are the things present in this oil. So we put this thing into a tank called as untreated tank. This is untreated tank. As you can see, this is the inlet line, this is the overflow line, and for these tanks there will be high level switch here, lower level switch here, and instruments will be provided. And on the top of the tank there will be heat detectors, and for the protection of the tank there will be foam injection system will be here, which will inject the foam into the gas oil if there is any fire incident. And then these kind of tanks are located inside a dike wall, where the dike wall is protected with foam system as well. So all kind of fire protection systems are enabled for the protection of these type of gas oil tanks. And coming back to the system, this is known as a floating section. So in most of the tanks, to suck the oil from the tank, we use a system called floating section. Why we use a floating section? Because always the suction will be from the top side, because when this oil comes, we will give this oil for some settling time. So once the settling time is done, all the sediments, all the particles will be deposited at the bottom of the tank, nearly somewhere here. So you can the customer can always get fresh fuel from the floating section, because the suction will be always from the top side of the tank. So the oil will be getting through this suction. So all the sediments will be accumulated at the bottom side, and fresh oil can be withdrawn from the tank with the help of a floating section. As the level comes down, the floating section will the floating section suction point will come down. As the level goes high, the floating section will go high. It will be floating all the time. It got a fuel elbow here, and then from there the oil is withdrawn into a pumps. These pumps are known as transfer pump. Transfer pumps are normally, most of the case, transfer pumps are centrifugal pumps. This is the pumps. The number of pumps can be decided by the design of the system of the requirements. It can be n number of pumps based upon the gas turbine requirements. This is a typical system of a transfer pump. The oil comes here. We have provided a isolation valve for the system. Most of the transfer pump is equipped with the duplex filter mechanism. It means there will be two filters, and one filter will be in service and the other one will be standby. So there are isolation provided across the filter ports. So if this pump is operating, one of the filters will be in service. Let's say this filter will be in service. So this valves will be in open condition. So the pump is running 24/7. And over a period of time, this filter will get DP, differential pressure. It means the filter suction strainer have choked. So what we're going to do? So what will happen? We will change out the other one and we will isolate this, and we'll take this for maintenance. It means the duplex filter is same like a bypass system. It will, if one filter is in choked, you can bypass, you can change out to the next filter and keep the pump in service 24/7. That's the main purpose of this kind of duplex filters. These duplex filters cleaning mechanism can be either self-cleaning or manual cleaning. Self-cleaning means there will be auto backwash facility provided to this kind of strainers. So whenever there is a DP, the system will automatically take over the cleaning process and it will clean the filter while the pump is in service. So there will not be any manual intervention required. Let's say these filters are not self-cleaning type, then manually we have to open the filter ports and then we have to clean the strainers and put it back into service. So this is a pump. As I told, this is a transfer pump. These pumps are normally, most of the case, these are centrifugal pumps. From the pump, it goes to a device, an equipment called centrifuge. Centrifuges are gas oil purifiers. It purifies the oil. So it will take out all the sediments from the fuel and it will be taken out to a safe location, let's say a drain collection point, and then the clean fuel will go out of the centrifuge. So centrifuge is a device which is used to clean the oil. Basically, centrifuges are used to clean the oil. The principle of centrifuge I'll be discussing later in a new video, but just for now, just understand that centrifuges are used to clean the oil to the OEM specification. It can remove potassium, it can remove sodium, all kind of impurities can be removed with the help of centrifuge. From the centrifuge, clean oil, as you can see, clean oil will be transferred to another tank. These tanks are normally known as clean tank or treated oil tank. So you can see both tanks are almost similar. It also got a suction, this suction, floating suction, and these tanks also have level indicators, level transmitters, level switch, heat detectors, dike wall protections. Everything is enabled for this tank also. Fire protection is a must for this. All systems, fire protection is a must. If you look at these tanks, let's take a time to talk about these tanks. As I have told about these level indicators, all kind of instruments. And one more point, what we have to notice is that once that this tank has to be drained at least daily or weekly once, because the oil which you are putting inside may have some amount of water particles. So since the water is heavier than oil, all the water will be accumulated at the bottom side and the oil will be floating on the top of the water. So if you're draining this, we have to manually drain this tank every other day or weekly once to take out the accumulated water inside these tanks. That's the purpose of these drain valves. As you can see, I have also mentioned a drain valve here. These drain valves are provided to drain the tank, to drain out the excess amount of water inside the tanks. Normally gas oil tanks are not coated inside. It means they are not painted inside. If you look at a gas oil tank very closely from inside, you will see only the bottom 2 meters will be painted. On the other surface, it will not be painted because this will be the portion where we will have water accumulation. So to protect that area, we normally paint less than 2 meters of height. So we have to drain these tanks weekly once. From this floating section, coming back to the system, from this floating section, oil will be sucked into the floating section and it will go to a pumps. It will be almost similar to these pumps, these transfer pumps. These pumps are normally called as gas oil forwarding pumps. This could be also a centrifugal pump with the same kind of filter ports and filter mechanism over here, and it could be n number of pumps based upon the requirements. From there, this oil will be pumped into the another pump which is known as booster pump, because normally these pumps cannot build. This is a centrifugal pump, the single stage cannot build the required amount of pressure required for this gas turbine. So this pump will pump this oil into the suction of the gas oil booster pump, where it will be boosted to the OEM requirements. Once the pump develops the pressure, there will be emergency shut-off valve, control valve. Several valves will be provided to feed the gas turbine with the required amount of gas oil for combustion. So this is about the gas oil system for a gas turbine power plant. Thank you so much.